Okay, this is lesson 45. For some reason it got erased from the top of my lesson. But you know, it's lesson 45. It's conditional permutations in two-variable analysis using a graphing calculator. So let's just jump into these. We've done some of these kind of problems, but now we're going to have conditions on our permutations. Permutations, the order matters. Combinations, the order does not matter. So this question is saying how many odd counting numbers can be formed from the digits 3, 4, and 5 if no repetition of digits is permitted. So we could have 3-digit numbers, we can have 2-digit numbers, we can have 1-digit numbers. So let's just think of how many odd 1-digit numbers there are. So I can't really draw these boxes very good, but let's just try. Say you have 1 digit. How many odd numbers can you put in there to make, how many numbers out of these 3 can you put in there to make an odd number if it's 1 digit? Well, we could put a 3 in, or we could put a 5 in. So there's 2 1-digit odd numbers. Okay, now we have 2-digit odd numbers. So we have to think, if it's going to be an odd number, it means the second number has to be odd. So how many choices are there for odd numbers? There's only 2. So we could either put a 3 here or a 5 here. How many numbers can we put here? Well, if we already used a 3 and a 5, or a 5, there's only 2 numbers left that we could put here. So there's going to be a total of, remember we multiply between there, so there's going to be a total of 4 2-digit odd numbers. Okay, now we need our 3-digit odd numbers. 1, 2, 3-digit odd numbers. So to be an odd number, this has to be odd. So we can either put a 3 here or a 5 here. So there's only 2 possible numbers that we can put here. So if we use one of the numbers, there's only 2 numbers left to put here. And if we've used a number here and a number here out of the 3, there's only 1 number we can put here. So the total number of 3-digit odd numbers is 4. So we just add those all up. 8. So there's a total of 10 odd numbers that can be formed using the numbers 3, 4, and 5 if no repetition of the digits is allowed. Let's try another one. Find a number of odd 3-digit counting numbers that are less than 600. So right away we're going to start with 3 digits. We don't have to worry about 1-digit or 2-digit numbers. So I'm just going to put my 3 boxes. In the book they kind of connect them. Or sometimes you can just do these kind of lines and fill them in. So we need odd numbers, and we can use any counting numbers. So the counting numbers would be 0. Actually, 0 is included in these. I didn't think 0 was a counting number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all the counting numbers. So 3-digit odd counting numbers that are less than 600. First thing is we need to figure out if it's going to be an odd number, the last digit has to be odd. So how many odd numbers do we have? 1, 2, 3, 4, 5. So 5, there's 5 possible numbers can go there. Does this one say, this one doesn't say that you can't repeat the digits, so you can repeat the digits. But only 5 can be used in this one. Now we need the number to be less than 600. So how many would give us, if we had a 6 here, that would be too big. So the only numbers we can have here are 5, 4, 3, 2, and 1. You can't put a 0 here because then it wouldn't be 3 digits. So there's 5 possible numbers that we can put here to have a number less than 600. Since repetition doesn't matter, we could put any one of these 10 numbers in the last spot. And so we would just multiply those numbers together. 5 times 10 times 5, and we would get 250. So there's 250 numbers, odd 3-digit counting numbers that are less than 600. This is a pretty handy tool to know how to do. Okay, let's try a couple more. These are slightly fun. lesson 45. Let's see if this one is right. Okay. This one's a little bit different. 5 math books and 4 English books are on a shelf. How many permutations, that means order matters, are possible if the math books must be kept together and the English books must be kept together? So there are 5 math books and 4 English books on a shelf. So here we go. We got to make our blocks. Let's see, I don't know if this is going to work or not, but we have 5 math books. 1, 2, 3, 4, 5, and the English books are much bigger. 1, 2, 3, 4. So we have our 5 English books. So we can put, it doesn't matter what order you put them in, so we can have book 5 here, 4, 3, 2, 1, and our 4 English books here. And if we multiply these all out, we can change these order around. Just I guess I said order doesn't matter, but you can't, I don't know what I'm saying, but just multiply all these together, and we're going to get it would be 5 factorial times 4 factorial, which would give us 2,880 ways to put the books there. Alright, let's do if the English books come first. So if the English books come first, we're going to have 4 English books and then 5 math books. 1, 2, 3, 4, 5. So here would be our 4 English books. You can see it's going to be the same thing. And then our 5 math books. And so it's going to be the same thing. 4 factorial times 5 factorial is 2,880. And if we add those all up, we're going to get 5,760 possible combinations of how you can put the book with the math books all together and the English books all together. Okay, example 4. How many different 4-digit odd counting numbers can be formed if no repetition of the digits is permitted? So we have, this is the same thing, we're going to make a 4, let's make 4 spots here. Odd 4, now we wrote the counting numbers before, 0 to 9. How many different 4-digit odd counting numbers? So if it's odd, we know that we can only put, there's only 5 odd numbers in the counting numbers. So we're going to put the 5 right here. We're going to use that first. This one's no repetition is allowed. So 4-digit counting numbers. Okay, we can go to the next one. We can't use the 0 because then it will be a 3-digit number. We already used, so we're down to 9 numbers. We already used 1 number, so we have 8 possible numbers that can go here. This one we can use the 0, but we can't use 2 of these numbers that have already been used, so that would be 10 starting numbers. We've already used 2 numbers, so that would give us 8 here. So we have 10 numbers and we used 3 of the numbers, so that would give us 7 right here. And so if we multiply those all together, we get 2,240 different odd, 4-digit odd numbers that can be formed if no repetition of the digits is permitted. So if we understand the difference between the repetition, if you're allowed repetition, we could have put a 5 here, a 9 here, and then 10, 10. But since we can't use repetition, we don't have, at this point we only have 7 numbers left because we used 3 numbers already. Okay, last problem. An elf, a gnome, a fairy, a pixie, and a leprechaun were to sit in a line. How many different ways can they sit if the elf and the gnome insist on sitting next to each other? This one's a little bit trickier. So we have an elf and the gnome. So here we go. We have 5 spots. And if the elf, let's give him a capital E. The elf and the gnome, if they have to sit next to each other, they're going to be here. And that means that we have, out of the 5, there's 3 seats left. So we can do 3, 2, 1 here, and that's just one way. That's going to be 6. We have to place this guy all different places, see how many places he can go, or they can go. So 1, 2, 3, 4, 5. We could have, we could put the gnome here and the elf here, and then we'd have 3, 2, 1, and that would be 6. So what we really need to figure out is all the different places where the gnome and the elf can sit together. So we can have the elf and the gnome sit here, and then we would have 3, 2, 1 here, or we could switch those up. So what we're really finding out is how many different places these elf and gnome could be. We could have the gnome, elf, and then 3, 2, 1. So far we have 4 of them, and you can see we could also put the elf and the gnome here, then switch them, elf and gnome here, and then here, and then switch them here. So there's 8 possible ways we could put the elf and the gnome, and then so we would really have 8 different ways to put them, so it would be 8 times 6. And that would be 48 ways that they could sit if the elf and the gnome had to sit next to each other. So hopefully that all makes sense, and since we're in the middle of a class, you can ask questions from there.